Again, feel free to say hello in the chat before we get started. This is Teaching and Learning Statistics with Desmos. Hi, Walter. Boston was at Boston last year for NCTM. Had a wonderful time, although it was a very quick trip. Very good to see you. I will apologize. Dealing a little bit of a cold today, so hopefully my voice is fine. Maybe a little nasally today. I think the whole world has the cold, right? Give it a minute or two to allow people to say hello. British Virgin Islands. Oh, that's exciting. Well, welcome. That's someplace I would love to be able to visit sometime. All right. So if you ever need professional development in the Virgin Islands, feel free. You know to look up first. We're friends, right? Fantastic. Yeah. Yeah. I usually get it when school starts. And once you get back into the bacterial stew, you just kind of, it just happens, right? It just gets you there. All right. We'll give it about 60 more seconds. Let people wander in. But then again, this is meant to be a recording. This is not meant so much to be live, but as a resource for people to use later. So it is absolutely fine. We'll see who wanders in. Now, the problem with hiding the taskbar is I can't see the clock anymore. So 7:01. Okay. We'll give it till 7:02. And then we will get started. Very excited to share session 3 here. This one is all about inference. Hello to our friends who just entered. Feel free, if you're a subscriber, to say hello in the chat or become a subscriber. We'll get started. All about confidence intervals and hypothesis tests. And I'll be honest, so within the last year, I was part of the teacher team that helped consult, I would say is the best word, on these new features. And the confidence intervals hypothesis test, I'm really just thrilled at how they came out, and I hope you are too. I'm going to show you some moves today, maybe some things you didn't know, and some little teaching strategies, some things I think might be helpful as you're thinking about how to teach and learn statistics here with Desmos. Okay, so let's get started. So first of all, this is the third of a 3-part webinar series. The first was investigating 1 variable and 2 variable data sets. The second was probability distributions. They are currently living on my YouTube channel. You can find those at any point and go back and forth. And this one is the third one, all about inference. If you contact me afterwards, if there's a clamor for more, people want specific moves, maybe I will do more, but we will let kind of the school year marinate and see what's happening. But I felt like there was enough clamor out there for some teaching and learning tips with this fantastic tool of Desmos that now has all these statistics features. About me and what this is all about, I'm a high school teacher just outside of Philadelphia. I've been an AP Stats teacher since 2004. I'm also involved in AP Stats reading, but my other world is also I've been heavily involved in the Desmos world. I was in the Desmos Fellows Cohort 1, which I think was in 2017 or something like that, and on the Stats Advisory team just last year. About this event, chat is available, but you need to be a subscriber. If you do subscribe, I think there's like a 5-minute lag before you can post a comment. It's pretty quick. And this one might be shorter than the last 2. I think this is more like nuts and bolts and not as much exploratory as my first 2 webinars, but I could be wrong. I didn't time this one out. So hopefully at the end, there'll be time for Q&A for any burning questions you might have. And this will remain on YouTube for your viewing pleasure. What I mean by that is sometimes I go very fast and methodically through these ideas. If you want to try to work through the examples with me, that's great. If you want to watch and then try later with the recording, maybe a cell phone with you, you could also do that. And community, hopefully you found this webinar through a couple communities, the AP Stats Teachers group on Facebook, and maybe AP Community on College Board are great places to ask questions and get answers. So what we're going to do today, no big surprises what we're going to do today. We're going to talk about proportions. We're going to look at confidence intervals and tests. Simulating with binomial, I actually may not do that one. I'm going to swap that one out for a different activity, but we are going to talk about means and then chi-squared. So we're going to look at all the different types of tests we might want to do. I am going to avoid inference for slope, but if that comes up at the end, I can show you how to do that. But that's more of a niche topic than anything else. And then recap and questions and answers. Okay. So for these, I really do have some questions here, and many of these questions I pulled from AP Classroom. And they're pretty basic, and you see these type in any textbook out there. So we have a random sample of 80 people was selected. 22 of the selected people indicated it'd be a good idea to eliminate the penny from circulation, which I think we're actually doing, right? I haven't heard of that again. What is a 99% confidence interval constructed from the sample proportion p hat? And then we want to know if this shows difference from 10 years ago when 18% were in favor of eliminating the penny. Is there evidence that the proportion is now higher? So as I switch to Desmos, Let me try to remember some things. Sample size is 80, 22 successes, 99% confidence interval. Let's see if I remember those things. So let's head over to Desmos here and full screen. But I will rely on my chat people to remind me of what those numbers are. Okay, fantastic. So let's get started. So we are going to do a confidence interval. So where we're going to go is the brand new Inference widget. If you go under the plus where we add items, this is the place where we would usually add expressions and notes and tables, folders and images. We now have this thing we call the Inference widget. And that's what I call it with my classes too, the Inference widget. And it looks like this. This is where you get probability distributions. Yeah, probability distributions are under the Inference widget, which might be a little strange, but there they are. But what we're looking at is inference for quantitative data, which we will do later, and inference for categorical data. We will start with a z-test for proportion, but notice our other options here as well. So let's do a z-test for proportion. So right away, I am asked for sample, the number of successes and the sample size. I think I remembered. There were 22 successes. I can tab over, and the sample size was 80. And at this point, if there were a second sample, and I don't think I'm going to do a two-sample procedure here, we could create the test, and let's see what happens. Okay. Right away, notice you don't need to know Z prop test or anything like that. That's just Desmos language for it. It took the information and put it into an appropriate command for us. I could have just typed Z prop test if I wanted to. In fact, Z prop test, if I go under the keypad and look under functions, you will find things like Z prop test under inference here. I can see Z prop test, but I just think the inference widget is going to be the way for most people to go. That's just fine. And notice 22 and 80. Confidence interval. We have two drop-down arrows here, confidence interval and significance test. Under confidence interval, right away, I see my confidence interval. It does default to a 95% confidence interval, but I can change that easy to 0.99. I notice a couple things. From 0.95 to 0.99, it did get wider. So we have this visual of the confidence interval. So if I want to drill down from 99 to 98, to 97, to 96, to 95, back up to 99, I can just change that number if I like. A couple other things we can do. Anytime we see three dots, that means there might be something interesting worth looking at. Here, I can get the lower bound, the upper bound, the point estimate, 0.275, and the standard error if I need it. So if I wanted to figure out the value of, was it square root of p hat 1 minus p hat divided by n, it is given there for me. And if you click this little box, it will just put it here. If you wanted to use it in some calculation, it is there for you. Also, in my confidence interval here, if I hover over the middle dot, it gives me the point estimate as well. So we can talk about the symmetry here. We can also talk about the margin of error somewhat easily by going between the distance from the point estimate to the endpoints. And again, for those people who just entered, welcome. Feel free to use the chat to let us know where you're from and just say hello. And if you have any questions as I'm going along, feel free to just chime in at any point. It's great to see you all tonight. So my confidence interval is 0.99. Well, my confidence level is 0.99. My interval is 0.146 to 0.404. All right, so let's go back to the screen again. There was a follow-up there. Similar survey from 10 years ago showed that 18% of Americans were in favor of eliminating the penny. Is there evidence that the proportion is now higher? Okay, so let's go back. Let's take a peek here. Let's full screen again. I was like to full screen these things. So now at this point, I want to do a test. And notice a couple things. My null hypothesis defaults to 0.5. But in this case, I believe the null was 0.18. That was the previous year. We also wanted the greater than. So it defaults to the both. It defaults to two-tailed, but we would like the right-hand test here. And I've given a few things here right within the expression list. The test statistic of 2.212 and the p-value of 0.013. So it does appear that we have, at the 5% level, evidence of an increase in the proportion of people who want to see the penny go away. So bye-bye penny. But again, whenever I see three dots, interesting things happening. What do they have under the three dots here? These three dots, we get the z-score, p-value. I could pull either of those out. Let me click one of these. And notice it gives me a little calculator syntax. So if you ever want to take a deeper dive and really play with the commands, you can get them in the three dots and then toy around with them a little bit. But the other piece I also like here is I can export the significance diagram. So let's see what happens when I do that. So on my screen, oh, there you go. And also zoom for us. I get an idea of what's going on here. And it really just gives me the normal distribution. It gives me the z-score curve, which has 2.212 as the z-score. So there is inference for proportions. So I'll pause for any questions people might have, any comments. but we're just going to keep on moving along. And I hope you really like, I really do like for student learning that we have the confidence interval and the significance test here. So if we think about, we want to do a two-tailed test and we want to talk about how does the p-value confirm or agree with the confidence interval. I notice here 0.18 is captured by my confidence interval. Therefore, it is still a plausible value for the true population proportion. And at the 1% level, I would not reject, and that is backed up by my p-value. So it's somewhat one-stop shopping to compare confidence intervals and significance tests together. And I think that's really going to be pedagogically something I'm going to change. Not that I didn't do that already, but I think here it really reinforces the idea of confidence intervals versus significance tests and what helps us provide evidence towards a claim. So there is one prop Z test. Or whatever you want to call it, Z-prop test. So you notice I can't get away from the TI language, can I? But that's okay. All right, let's go back to the slides. So here's what I'm going to do a little bit of a exploration. So this is a question I made up, but it's a pretty standard multiple choice type question, maybe a free response question. I will select a random sample of adults to create a 95% confidence interval for the proportion of adults who use rideshare services. What is the smallest sample size that will result in a margin of error no greater than 4 percentage points? 95% CI, margin of error, 4 percentage points. So let me remember those things. All right, let me come back here. I'm going to start a new graph. Click the folder. I start a new graph. And let's full screen again because that's where I'm going to go. So just recall these type of questions. These are often questions students use the formula to do, and I would encourage students to still do these by formula. But let's investigate this a little bit. Under the plus, under the inference widget, let's look at a Z test. Now, I'm not really given any information here, but recall when we do these with the formula, we assume a p hat of 50-50, a 0.5, 0.5. I'm going to do that same thing here, but I have to give successes at a sample size. So I'm just going to give representative 10 and 20. So there's my 0.5. And I'm going to create a test. Okay, here we go. So let's take a look at that confidence interval. So there's my 0.95 confidence interval. Okay, and notice right now my point estimate is 0.5. So I can see my margin of error right now is what? 0.219, the distance between 0.5 and 0.719. But I want a margin of error of 4 percentage points, so 0.04. So what can we do? Now, if you're like students, what they'll start doing perhaps is start playing around with those numbers and maybe find the numbers. They'll do a little, hopefully, intelligent guess and check. But let's get a little bit more Desmos-y about this. Instead of 10 and 20, let's make this N and my sample size then 2N. Okay, so instead of 10 and 20, N and 2N. Actually, let me go back and do that differently. Because the second number is my sample size. Let's make this one N, and let's make this 0.5N. There we go. I like that. And the sample size is really what I'm looking for, right? And notice nothing is active here because we don't have a sample size. So we will add a slider. Yes, I'd like to add a slider. Slider is going from 2 to 30 right now. I don't think 2 to 30 is going to do it. If you've never worked with sliders before, you click either endpoint. So I'm going to click the 30. Let's go from 2 up to, 400. And we'll step by one. And now let's see what happens. Now 2 is clearly not good enough. But watch this. Look at my confidence interval as my sample size is getting bigger and bigger. And now let's think carefully about what we want here. I right now have a p hat of 0.5. I would like a margin of error of no more than 4%. So that means I'm looking for 54% here or 46% on either end. So what sample size does it take to make that width 4% on both sides? And eventually, if I do this, I slide. I think it's like 300. Oh, no, it's not 300. What is it? Maybe it's 400. No, maybe it's 400. It's 100 and 400, I guess. 2, let's go up to 600. What, 4%, right? Oh, was it 95 or 90? I guess it was 95%. Yeah, okay. So I'm going to go to, eventually I get it here. Oh, maybe it's just 600. Oh, there it is. Seems like right around, now it does round off a bit here. So, but it looks like when I get to around 600 and it's rounding off again, but I also could look at those values here and play with it just a little bit more. So I think it's a very interesting way to get students to think about, notice as my sample size decreases, my interval is actually getting wider. And I'll notice that interval is not getting wider in the picture there. It only gets wider or shorter based on the confidence level. So that defaults to 99% is the highest, so that's the widest it will be, and then it goes down from there. So notice it's not getting shorter here, but I can see by observation with the 2 endpoints that it is, in fact, getting shorter. So I think it's a neat little investigation I'm looking forward to doing with students this year. Okay. That's what we have for proportions. I do want to point out one last thing with proportions. Under the inference widget, if you had 2 samples, you just click plus and you can do 2 samples. And I don't have any examples for 2 sample here, but I will within means. So there's proportions. Okay, again, comments, questions. If you entered and I didn't say hello to you, feel free to say hello in the chat and be part of the conversation today. Let me start a new graph here. Fantastic. All right, let's see what we have for means. A couple examples for means. Let's see what we have here. Another question from AP Classroom. This one is about caffeine in 16-ounce coffee cups. So I highlighted the main idea here. We have a mean and standard deviation of the amount of caffeine in a sample of 16, it's actually 40 16-ounce cups. We have 2 numbers there, and we would like to construct a confidence interval for all 16-ounce cups. And it does not give me a confidence level, but that's okay because we're going to play around with that. All right, so I have 2 numbers here. I have to try to remember 159.88. Okay, I have paper. Write down 159.88. A good teacher would have written these down beforehand, right? And 36.72, and my n is 40. All right, so hopefully I can read my scribble scrabble in a moment. All right, so let's go over to Desmos. All right, so again, my inference widget, plus look at my inference widget. This time we have quantitative data. This time we are doing a t-test because the standard deviation we have comes from a sample. So we'll do t-test. And now we have a couple choices here. We can put in a list of data. I will show you how to put in a list of data in, or we can put in summary statistics. And we have summary statistics here. Notice sample size is 40. Mean, I wrote down 159.88. Standard deviation, 36.72. Fantastic. And let's go ahead and create that test. Okay. And again, we see on the screen t-test. If you wanted to type in t-test, let me do it on the next line. If you just wanted to type in t-test, it will prompt you. Oh, it doesn't prompt you for the things you need. I thought it would prompt you for the things you need. It probably should. I'm going to make that recommendation that you need sample size, mean, and standard deviation. Now, if anyone in Desmos is lurking, we want to put those things in there. But let's go to the confidence interval. So it defaults to 95% confidence interval, 148.1 to 171.6. Looks great. But you know what? It didn't give me a confidence level. It just kind of let me pick a confidence level. And let's say we wanted to investigate what happens with different confidence levels. So here comes another teaching tip. Where we have 0.95, well, keep in mind anywhere in Desmos where you could plausibly place a number, you can put a parameter there. So instead of confidence level just 0.95, let's put confidence level of P there. And we are invited to add a slider. Yes, please, let's add a slider. And notice this one, because Desmos is intuitive at times for things like this, it wants between 0 and 1. Now, I'm probably not going to go all the way down to 10%. Well, we can play around with that. But let's play around with this a little bit. So, there we go. So we can go all the way down to, now I'm not going to do we normally are not going to do a 19% confidence interval. There we go. But we can go up and do a 80% is usually our shortest. And notice how that is growing as we slide over. 89, 90, 91, 92, all the way up to 99. And in fact, it will let you go to the 1. Watch what happens when you go to 1. If you want to be 100% confident, you can do that. Can we ever be 100% confident? Sure, we can be 100% confident. Or I could overtype the P and be 0.999 and have a very wide interval. And notice it's arrowing out of our range here with a point estimate of 159.9, which is the number that I gave it. So I think it's very interesting to play with this. And actually, you can actually play it. Now, going down to 0 is going to be ridiculous. I might actually set this between, 80% and 99%. And have students play and think about it. And it kind of backs up the idea of the interplay between confidence level and the width of a confidence interval. And that also means margin of error, because we can visually see that margin of error growing, shrinking as we have different levels of confidence. So again, hello to the people who have answered. If you're a little late and you want to say hello in the chat, feel free to. We're talking all about inference tests and confidence intervals tonight. Okay, a couple more pro tips. Let's go back to the slides. So there's for means. Here's where I want to go next. So my next screen, what I want to do next. I want to do a 2-sample thing. I want to show you how you can enter in data. So how do you enter in data? Let's just make a new one here. So I'm going to go to new graph. In the description of this video, there is a link to something I often use. It's just Major League Baseball data, which sometimes I use to create things in class. So I'm going to use this data, although I will readily admit this is not the best data set to use because these are not random samples. So just kind of hold your nose as we're going through here. But I have data here from 2017 and 2018. Again, this is linked in the session description. And also, one year I got very ambitious and pulled the data from 2021. Like there's like 300 players in here, and their launch angles and exit velocities. So if you ever need a cool data set to play around with in a pinch, this is a good one. But let's say we wanted to do a 2 sample where we wanted to look at the home runs between 2017 and 2018. Okay, so let's do that. So I'm going to press escape here and start over. So I can take the home runs from 2017. I am not taking the label with it. I'm just taking all the numbers. And because I'm a PC user, I'm going to control C. The Mac users was that little Apple C or whatever it is. Control C? No, it is whatever it is for you guys. We'll come over to Desmos here. So let's go to plus. Let's do inference. Let's do a t-test. Now I have choices here. I could simply put the list of data here by copying it and pasting it rather. So I'm going to paste it. And notice a couple things occur. It puts it in square braces for me and puts commas in between it. So that's very nice, right? So it puts the whole list there, and I can scroll through and see the whole list if I like. There it all is. And now I can come get the 2018 data. Let's come down here. Let's get 2018 home runs. So you can copy and paste data in fairly easily. Control C. And come up here under sample 2. And Control V. There it is. 2 samples. Create the test. And it is all there. Did my confidence interval. So we're 95% confident that the difference in what I do again? The mean number of home runs for major league teams between 2017 and 2018 is between 1.79 and 32.88, which does seem to imply that there was a significant difference between the two of them, which is a bit surprising. We could also look at the significance test here, and we can see our test statistic and both things going on here. And we have left, right if we need to. But notice that, again, my p-value jives with my confidence level. 0 is not included by the confidence interval, and it probably shouldn't be because I have a p-value of 0.029. So these things back each other up. Again, I like to look at the 3 dots. Something new here, degrees of freedom, 56.69. I can also pull that if I need to, and I can also export the significance diagram. It is shown here. So anytime I see 3 dots, that is definitely something we want to see. Again, people feel free to use the chat, say hello if you have any comments, questions. We'll say I apologize. Sometimes I go very quickly through examples, but keep in mind this is a webinar. You can always rewind me, play me at half speed, make me go even faster if you need. Okay. I will show you one other thing we could have done to get those in there that I think is also going to be somewhat helpful here. So let me start over again with this. What I probably would do with this is I would make these lists before I do any inference. And what I mean by that is, let's get my home runs for 2018, H sub 18. So I just typed H18 and automatically subscripted equals. And now, since I already copied it, so I'm just going to paste it there. Hi, Corey. Good to see you. Yeah, I really like how the CI and the test are together. I think that's really going to be helpful. And now let me go back and get H of 17 equals. Let me go back and copy that again. Oh, it's under the MLB data one here. Let's go to 2017. Corey has been to all 3 webinars, I believe. She's my trooper. And they're all selected, so I should just be able to Control C and paste them in here. Because, and here's why I want to do that, before I do anything else, we want to make dot plots, or we want to make box plots. Let's make box plots. So if you missed the first webinar, I can make box plot of H sub 17. I can also make a box plot of H sub 18. I am going to zoom fit so I can see them. They're on top of each other. That's okay. I will offset 18 by, let's go by 3. And now there we go. I like that. So before I even do anything else, and oftentimes what I'll ask my students is, based on the box plots, do you believe there's going to be a significant difference in the mean number of home runs between 2017 and 2018? And at first blush, maybe there isn't, but now I actually look at the median here for 2017 seems to be around, was that 210? And for 2018 seems to be around 170, 175 or so. So if I think about it, and they both look roughly symmetric-ish to me. So the mean is probably close to those numbers. So I'm not too surprised to see that now I will do the test under inference. I can do my t-test. And now I can just type for list of data, H sub 17. And sample 2, H of 18. So there's a couple ways that you can get the information in on a t-test. Excuse me, folks. You can type it in. You can type it in directly with commas. You can import it as a list and just call it whatever you want to call it. And notice summary statistics is there as well. Now I can look at my create the test, and there's my significance test once again. So yeah, I really like how it's all laid out together here, all in one-stop shopping. Okay. All right, one last small thing to do today. We are going to look at chi-squared. We're going to look at a chi-squared example today. And then again, I said this might be the shortest of the webinars because I think most of this is just getting used to the different commands and seeing where they are and where they play together. So I'm just going to walk you through an example of chi-squared this time. Let's make a new graph here. Now for this one, go back to my slides. This is another AP Classroom topic question. A large regional, a national bank determines if each of its branches is profitable, not profitable, and where they are located, urban, suburban, or rural. Is there an association? No, what are they going to call this? Independence. Are they independent? Okay, association. So it's an association test between the two things. And like last time, I forgot to copy these numbers down. So I'm going to copy these numbers down on a slip of paper before I leave the screen. And we would look at the 5% level of significance. And I'll be completely honest. The one place where I thought Desmos getting inference was going to be a struggle was chi-squared. Because a year ago, there was no mechanism for putting in categorical data. And I really think not only did they find a mechanism, I really like how chi-squared is done here. So let me walk you through how we do chi-squared. And feel free to give your comments in the chat. Under add item, let me full screen again so we can see very well. Always like to take up all the real estate. Under inference, we have two chi-squareds. Chi-squared are independence association. There is also goodness of fit. I wasn't planning on doing a goodness of fit, but maybe I'll make one up off the top of my head at the end of this because it feels like we'll have time. So let's do chi-squared test for independence. That opens up this little table widget, which you can put in as many groups as you like. I've actually not load tested. I'm sure it doesn't go up to 50 in each group, but you can load test it. But here, I'm just going to type them in, 64 and 17. Group B is 39 and 22. And if I just arrow down, it will create a group C, 18 and 55. I could also arrow over if there's a third group there. So I just put them in there. Okay, now we're all set. Create the test. Now let's see what we got here. Now, the one thing I will say about chi-squared is because you're looking at tables, it does take up more real estate in the expression list. So something right away I'm going to do is between my graph and my expression list, I'm going to drag because I know I'm going to need more space. And you're going to see why in a moment here. Yeah, chi-squared takes up a little bit more real estate within the expression list. So let's arrow down. So this time we don't have confidence interval because we don't do confidence intervals for chi-squared, but we do want an observed and expected counts table. So let's take a look here. So notice it defaults to here my observed counts, 64, 39, 18, along with their expected counts. So very easy to find those. Also, some things you can click and get automatically are the contributions. These are the contributions to the chi-squared statistic. Now notice they are shown just as bars right now. So what I can see right away is that group 2, group A, whatever this is, I think this was something about banks in urban areas. I don't want to look back at the problem, but whatever this signifies, this seems to have the most contribution to the chi-squared statistic. So visually, I can see right away that this particular cell gives the most to the chi-squared statistic. But if I'm going to take a deeper dive, all the cells have arrows. Notice the little arrows. I click the arrow. Oh, I can find the observed, the expected, and the individual contribution to the chi-squared statistic by just clicking the arrow. So all this information is given. And any of these numbers, if I click the little export button, it will tell me the number here, and I can use that number. Okay. Okay. I can also get the totals. And again, the totals, it takes up a little bit of real estate, so you might have to drag over a little bit. Yeah, the chi-squareds take up a little bit of real estate to get all these things that we might like. But there's all the information we need right away. And then within significance test, there's my graph. My p-value is 0.021, so it doesn't appear there's an association between was it banks and where they're located and something about them, whatever it was. Degrees of freedom, chi-squared statistic. 3 dots, of course, means that I can do things with it, and I can export the significance diagram if I like. 2 degrees of freedom is not a very exciting looking chi-squared graph. Oh, but I can see my little shaded area here because my chi-squared statistic is 7.76, and I can see that right there. So yeah, I think the chi-squared is really neat how they did this here. So comments, questions, feel free to ask any in the chat. Hello to the people who have entered. Very good to see you this evening. I'll pause for a moment to see if there's anything people want me to talk about. Then let's do a real quick goodness of fit example. I'll be honest, I haven't done a goodness of fit for a while, so this might be something I stumble through. And then I'm going to work backwards. I'm also going to show you how to make an interactive confidence interval, because I think that might be something people want to see. Okay. All right, let's do a real quick goodness of fit example. I don't have one. What do you know? Do you have a favorite stat textbook? Yeah. Well, practice of statistics, but I'll say I've been using practice of statistics since 2004. However, I'm a biased. This is a biased opinion because I'm also creating videos for the practice of statistics, folks. But I always found that their work is very professional. They are people who are very in tune with how the AP exam is written, read, and with the materials. Yeah, I think it's just fantastic. But also integrate with some of the mathematic materials as well. I think there's a lot of good stuff out there. But practice of statistics is what I use. Okay, let's start anew. Let's go under the plus sign here. Inference. Let's take a look at goodness of fit. I actually don't remember. I haven't done a goodness of fit for a while. So we have observed and expected. So let's say that we have. So we have 4 groups. So observed. So let's say I'm going to try to do 100 of something. 100 of something, and let's say there's 30 in the 39 in the first group. Sure. 22 in the second group. 18, and then whatever's left there. I think 11. That gets me to 100, doesn't it? Yeah. Now, here's the thing with this one. If I create the test right now, it will default to the fact that it thinks that every group is going to be equal, that their individual P's are 0.25. However, you can say, well, what we expected, maybe it's a different ratio. Maybe we expected 40, 30, what do I have left? 15, 15. Okay. Walter, the author is Darren Starnes and Josh Tabor. I will type that in the chat for you. So Darren Starnes, Josh Tabor. Yeah, they've been doing the practice statistics for many years. Expected observed totals don't match. Oh, that's an unexpected surprise. Why don't they match? 50, 50, expected, optional. Why don't they match? 50, 50, 100. Who sees my math? Total don't match. They don't match? Oh, no, I'm short. Am I short? 39, 60, 40, 70. I think we found a glitch. Do we find a little glitch here? Observe the expected totals don't match. Yes, they do. 30, 50, 50 is 30. 30. Oh, I'm high. I'm high. Too many. I'd make this 29. Did it match now? 40? No, it was right the first time. Oh, wait a minute. I got to call Desmos. That's weird. Oh, no, they really don't match. This has to be more. All right, now they match. All right. This is me trying to do mental math in an evening. I was worried there for a minute. I was like, I think they do match. So if they don't equal each other, you'll get this error here. And now let's create the test. And we can find our observed here. This time it looks a little bit different because it's only one column. Here's our expected with the contributions to the chi-squared statistic. And this one, it will give it as a separate row or column with the totals. And we can do the significance test here with 3 degrees of freedom. So goodness of fit is supposed to disappear from the AP Stat curriculum next year, and I'm kind of unhappy about it. I really like goodness of fit tests. If you don't know, that's something that was on the chopping block, and I think still is. That's a shame, because I really do like goodness of fit. I might still do it anyway. I think goodness of fit is kind of a neat test to do. There it is. Okay. Any other questions about goodness of fit tests? And we'll do one last good thing before we call it a night. All right. Again, if you're lurking there and want to say hello, feel free to say hello in the chat. Always nice to hear people say hello. Okay, so here's what I'm going to show you how to do. I'm going to show you how you can make a little interactive about capturing with confidence intervals. It does kind of put some Desmos moves together. So again, I'm going to make a new graph here. And what I'm going to start with is I'm going to start with the normal distribution. And I'm going to call this normal distribution N because I'm going to do something with it. And also, let me get my screen back to where it should be like this. Okay. I just know the command normal dist. Again, that's under the widget. And I'm just making up a normal distribution here. Let's say it is people's heights. So 68 inches to the mean, standard deviation of 3. So there's my population. Okay. Now, I'm going to draw random samples from that population. We're going to call that R. R equals random, parentheses, N. So that would draw a single observation from N. And if you've never used random before, once you use random, on the top here, you get this double arrow for re-randomize. So I can draw individuals from the population and assess what's going on. Okay. But let's say we want a sample size of 30. So let's do sample size of 30. It's drawn 30. Okay. And now what I want to do is I know that my mean is supposed to be 68. So we do have a population with a mean of 68. I want to see what happens when I build confidence intervals. How often do those confidence intervals capture 68? So let's go ahead and do a t-test, or t-procedure rather. Go to my widget, t-test. My list of data will be R. I have this list of data, my random sample, R. And we'll create the test. And here I have my confidence interval. Okay. In fact, I'm going to turn off this red line. The normal distribution itself, I'm not interested in graphing. So I'm just going to click the dot here and get rid of that. And notice it looks like this confidence interval from the random sample does, in fact, capture 68. And it should, because the population mean is 68. But let's re-randomize. So let's keep looking. And I'm going to try to go fairly slowly. How long does it take me to generate, excuse me, a random sample that does not capture 68? That does. That does. Oh, right away. Fourth one. That fourth one right away did not. So my fourth one did not. Isn't that fun? I didn't have to wait for 20 or so of them. So right away, I'll have one that didn't. Well, there's the power of random sampling. How often should that occur? And if you can start talking me a type 1 error and capture rate, and when things should be captured, when they shouldn't be captured. Let's see if this is fair. Let's see if I can do it again. It shouldn't happen quickly again, right? Let's see if I get lucky. Can I capture 68? Can I not capture 68? Good. Nope, there's one. Too high. Or actually, the interval's too low. So let's play around with that. How can we make a visual out of this one? So let's make a visual. And this one is going to be a little funkier with some moves here. But again, keep in mind that you can always come back and emulate these moves by watching the recording. I'm going to come under the 3 dots here, and I'm going to grab the lower bound and the upper bound. And notice it brings them out there. Okay, brings me the upper bound and the lower bound. And in fact, what I'm going to do is I'm going to make ordered pairs out of them. So I'm going to make ordered pairs where those are the x values, but they show up on the y equals 1 line. So I'm going to take this one, put parentheses around it, and do comma 1. And I want another point, but I'm going to put them together in the same line. So I'm going to take this and copy it, and I'm going to put it here in this second line. And comma 1. So all I did there, let me move out here. So I brought those 2 things in, and now they're ordered pairs. Okay. So let's see if we can find them. So they're in the 60s. So let's do a little dragging over to the 60s. They should be sitting right over here. There's 2 points. Where are they at? There they are. There's my 2 points. I can zoom in a little bit. Okay. Let's make them a different color. I don't want everything black there. Let's go like red dots. Sounds good, right? Red dots. Additionally, I probably would like to connect them. So there's a couple ways you can connect things. I'm going to kind of cheat here. I'm going to use the polygon command. So if you don't know polygon, we'll take, excuse me, a list of points and make a polygon out of them. But since it's only 2, polygon is just going to connect them. So I'm going to connect them there. Okay. So let's zoom in here. 68 is the star of the show, right? And now I also want to make the line x equals 68. There's line x equals 68. Let's do a little bit more to it. Let's make it a little bit skinnier, like 1.5, maybe a different color, green. There it is. So now right away, I have this neat little interactive that every time I re-randomize, I can talk about capturing or non-capturing. And perhaps you're going to have students. You could make this for students. Oh, there was one that didn't capture and I went past it. You could build this for students and maybe have them take little tick marks. How often does it capture? How often does it not capture the true parameter of 68? And I can go really fast with it and see how often it does it. I saw a couple there that didn't capture. And then you could repeat it with 99% confidence intervals, for example. So there's ways to make interactives by combining previous Desmos skills of just plotting points, and there's one that didn't make it, with new skills of with the CIs and the intervals here. Okay. Well, friends, so that's about all I have for tonight. So this is all about inference. I'm very excited to be able to use these inference tools with my students. I will give it a side because I think we have a good bit of time left. And it's not that we have to do an hour, but I'm trying to get my clock going here. What time is it, folks? All right, let's on full screen. There it is, 7:39. Perfect. One of the questions I often get is, so how am I dealing with tests and quizzes now that I'm using Desmos? So I do teach high school. I have 2 sections of AP Stats. Some of my students have TI-84s. Perfectly wonderful. Keep using them. I will show you how to use them. I've used the TI-84 for years. Great tool. Let's keep using that. But when we investigate and we do Desmos things, they'll be doing Desmos commands with us because they're also going to be on the exam and they'll be able to use Desmos there if they like. So thank you, Walter. I appreciate that. So the one thing I'm going to be doing, so my district's learning management system is Canvas. And I just realized the other day that my district did purchase the lockdown browser capability. So what I'm going to be able to do is to assign a fairly blank quiz or assignment within Canvas and have students lock down their browser. And I'm just have the only thing on that quiz be a Desmos graph. So they can have their computer open and interact with the Desmos graph with a lockdown browser. And that's how they will be allowed to do tests and quizzes in my class using Desmos. But I think that's a solution that's individual to my classroom. That would be something different to what you have and what you have available to you. So we're trying to get more of those ideas out there to help teachers along. So friends, again, this is all online and it's ready to go. Feel free to give me any feedback. If there's any other moves you want to talk about down the road, just let me know. Feel free to contact me on Facebook or via email. If you want me to stick around, if you have any one-on-one questions for me, we can make this open house. But I hope you found value in this webinar series, and maybe down the road, I'll get a chance to see you all, perhaps in an AP reading or at a conference somewhere down the road. Thank you all very much. Have a great night, everybody. Thank you, Jess. Take care. You're welcome. And feel free to say things in the chat. Corey, it was good to see you again. Yeah, it's going to be fun. Yeah, I do experimental design first, so I haven't had a chance to do this yet. I'm only giving my first test. Yeah, Walter, yeah, the voice is starting to get a little nasally. I can sense it. So very soon, hopefully. Okay, with no further questions, we will end this about 60 seconds or so. Feel free to say hi, and that'll be the end of it. And okay, take care, friends.